Here is the circuit for Dusty. Dusty is Team Amperage Ally's engineered solution to automate dusting surfaces within the home. I'm going to run through the components real quick. So we have four HCSR04 ultrasonic distance sensors. This is going to be sensing anything in the front, back, left, and right. We also have the Arduino controller here. Um, Moving on to the DC motors, we have one DC motor controlling the left wheels, another that's going to be controlling the right wheels, and a third that's going to be controlling the rollers on the bottom of Dusty. Moving to the photoresistor, we have one photoresistor and then one resistor with 10 kilo ohm resistance. We also have two L293D motor drivers sitting on top of the breadboard, and then also the 9-volt battery power supply. Next, we're going to look into Dusty's code. So up here in the top, this is just defining the variables for each pin within the Arduino. During the void setup function, we're basically saying whether it's going to be input or output to Arduino. For instance, the motor pins are receiving outputs from Arduino, while the photoresistor is actually providing an input to Arduino. Moving into the void loop function, here we're setting the standards for the distance sensors. So we want to make sure that uh, when the sensor is triggered, we don't wait endlessly for an echo to respond. We also want to make sure that when we calculate the distance, we're only calculating for a one-way distance and not a round trip. Here we've set a lot of serial print standards. That's for us to watch the serial monitor and understand what data is being printed out as the simulation is ran. So here is basically setting the standard for what the Dusty is supposed to do based off the information that the sensors collect. So if all the distance sensors are greater than, this is reflecting 3 inches and 7.62 centimeters, um, the Dusty will be moving forward in that scenario. This will also be reading whether the light level is less than 100 or greater than 100. If it's less than 100, the rollers on the underside of Dusty will be engaging, which will be turning the microfiber cloth and actually dusting the surface as Dusty moves forward. The rest of the variables here are just giving different scenarios, whether there's an obstacle from the front, from the left or right. And then this program will engage the actuators on the left or right motors to turn left or right. And then if there's a obstacle in the front, as well as the left and right, then Dusty will stop. So I'm going to run the simulation real quick so you can see this code in action. So we're going to click Start Simulation. I'm going to start with all 4 distance sensors at a distance greater than 3 inches. And then the light is going to be as bright as the photoresistor can detect. So here you can see that we're meeting the first criteria that all distance sensors are greater than 3 inches, and both motors for the left and right set of wheels are moving forward, and the Dusty rollers are not engaged. But as soon as you get a surface less than 100, it's going to start engaging those microfiber cloth rollers to start dusting up the surface. So we can uh, tailor these sensors to work to the code. So I'll pick one. Let's make Dusty turn right. So to make Dusty turn right, we're going to configure the sensors, the distance sensors, to make Dusty turn right. So the statement would have to be the front distance sensor is less than 3 inches, and the right distance is greater than or equal to 3 inches, while also the left distance is not greater than the right distance. So these sensors are configured for a right turn. And as you can see, the left wheels are moving forward, the right wheels are moving backward, which would make Dusty turn right.